So I have you pull your worksheet out and look at number 9. Looking at number 9, it doesn't look like we're given much information. We're given the 30-foot span, and we're given the 9/12 slope and the 6/12 slope. Well, from that, we can find the angles alpha and beta. Just think of it as like being labeled A and B, only I'm using Greek letters instead of regular letters. Partly because it's just traditional in trigonometry to use the Greek alphabet for angles. How would I find angle alpha over here? Right there, that one's alpha, the fish. This angle here. How would I find that? Well, it's off of the 9/12 slope. Which is something, if this is 9 and this is 12, here's my angle. So alpha is simply going to be the inverse tangent of my 9/12 slope. (36.87 degrees). Beta. What's that going to be? How's that going to be found? Right here. That's going to be the inverse tangent of 6/12 slope. If I take the 6/12, there's my right angle, 6/12, here's my angle. Which is going to give us, not everybody at once. Yeah, 26.56 degrees. 6/12 is a common slope. 6/12, 5/12, 4/12 are angles that you should get used to. So 4/12, 18.43, 5/12, 22.6, 6/12, 26.56. What's that? Good. So now that we have that, we can find the angle up here, can't we? How do we find that one? 180, subtract those other two. Very good. 116.57 works for me. Now that we know all of those angles, we can find the length of this side and this side. Why does that do us any good? Well, we want to find the height here. And to find that height, if I know one of those sides, I can find the height based on the angles. So let's look at this side here. I have the 30 over sine of 116.57 degrees. See where I'm going with this? If I call this x, it'll be x over what? The sine of 26.56 degrees. So 30, come on, clear it out. There we go. 30 times sine 26.56 divided by, whoops, I gotta close that out. Divided by the sine of 116.57 is 14.998, so 15 degrees, or 15 feet, I should say. 15.00 feet. That's 15 feet long. Is that what everybody got? They're confused, Colt. 30 times the sine of 26.56, make sure you close the parentheses, divided by the sine of 116.57. 14.998. Did it work? Okay. Now that we know that that's 15 feet, now we can find this height here really easily because we have a triangle. It's a right triangle. This is 15 feet. This is 36.87 degrees. There's H. We have the opposite side and the hypotenuse, which is sine. Remember, sine of an angle is opposite over hypotenuse. We know the angle, so I'm going to put sine of 36.87 degrees equals, opposite side is h, that's what we're looking for. The hypotenuse is 15, so we put that over 1. Cross multiply and divide. Sine of 36.87 times 15 divided by 1. Sine of 36.87, close, times 15. 9 feet. These are right. What do you think? Not horrible? It is a lot of work. Think you can handle it? Okay. Absolutely not. Don't want to handle it, right? Number 10. Anybody finish off number 10 on their own? Anybody want to try to finish off number 10 on their own? If I could try it, you want me to leave it and work on it next time? Okay. Well, we'll leave number 10 then. We'll work on number 11. Spencer wants to leave number 11. For those of you who can't catch Spencer in the parking lot later, his home address is. Just kidding, Spencer. So what we have here, I'm going to redraw that. So there's what we have, a roof with that little bit of a dormer built into it. We're trying to find the area of the roof. Now, we're probably going to include the area of the back side of the roof here, although this problem doesn't specifically say whether you need it or not. In most cases you would, but we're going to ignore the back side of the roof right now because we can find that easy enough. So where we're going to start is, we know the span of this house is 44 feet. So the first thing I want to find is what is the length of the slope of this roof here, this length across down here. How do I do that? Okay. It's a 10-12 slope. The run is going to be what? 22. So if this is my height, 10 over 12 equals h over 22. So 10 times 22 divided by 12, 18.33. 18 feet 4 inches if you wanted to convert it to that, but we're going to use it again, so we're going to leave it as a decimal right now. Because we need this slope length. How do we find this slope length now? That'll be the square root of 18.33 squared plus 22 squared. Good. The second square root of the answer squared plus 22 squared gives us 28.64 feet. So now from that, we have 18 feet, 30 feet, and 18 feet. We could find the length of the ridge would be 66 feet, correct? Just by adding those up. We could find the area of this whole side here if it were just a flat roof. But we've got to deal with this dormer. There's what's that? There's two things we have to deal with on that dormer. One is we have to find this area here for each side. Of course, it's going to be the same, so we find one side and we double it. So we have to find that area, which is what I labeled W. And we'll double it because it's on each side. But we also have to deal with the piece of the roof that doesn't have to be covered because it's under the dormer. So let's look at that piece of the roof first. How big is that going to be? Well, if we look at this from the end, like this, the dormer comes off like this. What we need to find is the length of this slope here, right? That's going to form a triangle that's going to be that height, and the width is just going to be the 30 feet wide. We've got to get that height. To get that, we're going to look at this little triangle on the end here. How high is this dormer going to be? Well, this is a 15-foot run, right? Half of the 30. What's its slope? 10-12 still, right? Oh, 14-12 there, sorry. It's a 14-12 slope on that part. So 14 over 12 equals a new height over 15. And what do you get? 17.5 feet. That's 17.5 feet here. Oops, that's the wrong triangle. 17.5 feet up here. Does that mean that slope? Now, how do I use that 17.5 then to find the slope? Nope. This is 17.5 feet high, right? I've got to go backwards now to find that. You're trying to find this slope right here, right? And we'll need that eventually. That'll be, 15 squared plus 17.5 squared will give us that. We'll come back to that. We want to figure out that triangle that's missing out of the roof from the dormer sits on. So we need this slope here. If that's 17.5, we need to know how far is this? We go back to the 10-12. You got it. 10-12 equals 17.5 over whatever that run is now. So 12 times 17.5 divided by 10 is 21 feet. That's going to be 21 feet back there, which also means, of course, this ridge up here is 21 feet. It's going to be the same distance up here as it is down here. So that's 21 feet. So now this slope here is going to be the 17.5 squared plus 21 squared, and square root it. So the square root of 17.5 squared plus 21 squared is 27.34. So the area that is missing underneath that dormer is a triangle that is 30 feet wide and 27.34 feet high. So, of course, that area, base times height divided by 2. Giving us 410 square feet. So it's missing for that dormer. What's that? Well, that's the part that's underneath the dormer that's missing. We haven't found either side yet. That's the part that's on the main, this part down here sitting on the main roof that the dormer covers up, so we don't have to put shingles underneath the dormer, right? So that's the part that doesn't need to be shingled under there. Now we're going to come back and find this side of the dormer here. We know this is 21. We need to find this length here, which is going to be from the 15 and the 17.5, right? Make sense? Now we're back to what you were trying to do before, yeah. We've got, this was 30, so this is 15, and this is 17.5. So this here, square root of 15 squared plus 17.5 squared. So this comes out to be 23.05. So that's the slope. So the area of that triangle is 23.05 by 21, and of course divided by 2. Which gives us an area of 242.03 basically for each side. You double that to get 484.06 for the two sides put together. You get confused, Andrew? The 21 was the ridge here. So this is a right angle. So this is 23.05 by 21 divided by 2.
Oh, so that's right.
Yeah, that's why we had the 21. Yep. Not so bad. 12 and 13 are quite interesting problems.
They're both unsolvable.
No, they're not unsolvable. I'm not going to do either one of them. I'm going to do something similar to it. Yeah, W is 242. No, we didn't find Z, but we did find we found this here, right? And there was the 66-foot peak. You take this times the 66 feet and then subtract the 410 for underneath it that was missing for the dormer. It should come out to be about 1480. Subtract the 410, because remember, we had the roof here, and that's the piece that was missing underneath the dormer that didn't need any shingles. It was the 410. So you had the slope times the ridge, give it the whole area, and subtract out the 410. So anyway, on this one, let's say we got 60 feet. Yeah, let's do this. Let's make it more realistic. 48 feet here, 60 feet here. We're going to call this 130 degrees, 28 feet, 32 feet. I want to find a couple things. First thing, I want to find the area of this shape. It looks simple, but it's not. To find the area, I need to know this distance, I'll call it X. And this distance, I'll call it Y. So I can cut it across here. This is a right angle, so this will be a rectangle. Cut it across here, make a rectangle. This shape here is not very easy to deal with. This one. Let's draw it out a little bit larger. What I know about it is that this is 32 feet and this is 28 feet. I also know that this angle here is 50 degrees. How do I know that? 130, 90, and 90 leaves this has to be 50. Because that's 360 degrees all the way around there. This one here is probably also 130 degrees, right? So I know that much. What good does that do me? If I cut it across here, can I find that length there? You got it. I can use the law of cosines. That length there is going to be the square root of 32 squared plus 28 squared minus 2 times 32 times 28 times the cosine of 50 degrees. Second, square root 32 squared plus 28 squared minus 2 times 32 times 28 times cosine 50. 25.61 feet. Now what? Well, now that I have that, I can find this angle and this angle. How can I find those angles? Law of sines. You got 25.61 over sine of 50 equals, we'll do the smaller side first. We know both of those are acute because this is 90 degrees, right? So it has to be less than 90. But we always want to be in the habit of using the smaller side first. So 28 over sine of, I'll call this angle A up here, sine of A. So we're going to do sine of 50, close, times 28 divided by 25.61. And then we're going to do an inverse sine. Second sine of that answer, 56.88 degrees. That's 56.88 degrees. That's really not the angle we want. The angle we really want is this one up here. How are we going to find it? Where did the 33.12 come from? You know that's the right angle. Just subtract it from 90 degrees. Make sense? Okay. This angle over here, 16.88 degrees. Where'd I get that from? 180 degrees for the triangle. Nice try, though. So we have all three angles in that triangle, and we have one side. Guess what? You can now find these two sides using the law of sines. At this point, I'm going to trust that you guys can use the law of sines to find those two sides. Those three have to add up to 180 because they're in this triangle. I could have done the law of sines to get this angle and subtracted from 90 again. That would have worked too. I could have done the law of sines to get this angle here and subtract from 90. That would work as well, but you weren't talking nonsense. I was just picking on you. Now, I'm going to give you guys one more worksheet. Now you should know everything you need to know to finish this worksheet off. I'm going to give you guys one more worksheet to take with you since I'm not going to see you guys until Friday now. Maybe you'll see. That's why you guys usually get in late at night, Thursday night, don't you?